Great. Thanks. Good afternoon, everyone. Thanks for taking time to join me on this talk about Agentic Data Engineering. I'm aware that the bar is not too far away, so I'll crack on. Okay, so here's what I have for you this afternoon, really 5 kind of areas. Quick few slides of intro, a bit about what is an agent, and that's an interesting discussion in itself. A little bit on the language ecosystem. I've had quite a lot of people talking about models. I think it's always important to level set on that stuff. And then I'm an architect, so I'm going to talk about patterns and some boxes and some lines, and then apply that to data engineering. And then we'll look at some products, so things in the market that are already using agentics, and perhaps a little bit look forward to what might be coming, and then finally a quick call to action. Okay, so first I'd like to acknowledge the traditional custodians of the land on which we meet today, the Gadigal people of the Eora Nation, and pay my respects to the elders past and present, and extend that respect to the Aboriginal and Torres Strait Islanders who may be with us today. The traditional custodians have been on this land for some 40,000 years, where I've been here for a humble 40 years looking at technology. Most of that time I had a very long career in the UK with British Telecom. I started out in a lot of streaming, network analytics. I ran the enterprise data modeling team for a long time. Got into domain-oriented design. Spent a lot of time working with lots of different Oracle products, Oracle databases, all that stuff, all the client-server era. Took British Telecom through the whole big data journey, which is, it feels like we're going through another one of those hype cycles again. And we did a lot of streaming, so early adopters of Kafka on that stuff. Moved into the cloud, so we did then, just as I was leaving there, we were moving the whole Hadoop stack into GCP. So classic sort of journey. And then I moved on, spent some time in life sciences, on through consulting, and then I'm now currently with Westpac. So just to give you an idea, perhaps a bit of audience participation, a nod, or if you're brave, perhaps a hand. Who here is from a vendor organisation? No, good. Nobody's going to try and sell me something as I come out the door. Anybody from a large corporation, this bank? Yeah, a few of those. Good. Okay, so you're my people. You'll understand all the governance and pain that we have to go through. So, okay. So a quick grounding slide. And a few light-hearted disclaimer. The views here are expressed are mine and mine own. I'm here as an independent practitioner. I'm not representing any employers, past or present. So don't take this as any policy statements or so forth. But it is all grounded in stuff that I've worked on, either in current role or previous roles. Is there anybody here from the press by any chance? Yeah, okay, Andy, I know about you. Okay, it's fine. Good. Okay, relax. Okay, so first thing, so after the intro then, so what do we mean by agent? So, and language models, we need that shared understanding of what we mean by an agent, because there's plenty of ambiguity in this space. So, you know, it's not that kind of agent. Okay, I put this slide in there really a bit light-hearted that I haven't yet found a really good universal definition of agent. So if you're looking for one on the web, don't be worried. There are lots of different opinions out there. It's a bit like big data. The sort of the story about, was it the Dan Airley quote? Everyone talks about it. Nobody really knows what it is or how to do it. Everyone thinks everyone else is doing agentics, and so everyone claims they're doing agentics. It fits all over again. So I just wanted to put that one up there. A good starting point is always academia. So I did a BT. We did a lot of machine learning back in the day, predictive models, and worked with a lot of data scientists there. And we use the kind of academics. You may see. If you see a definition like this, somebody puts this one up, they're almost certainly a data scientist. The Russell and Norvig book is still used in 1,400 universities in undergraduate text. It makes this very generic statement about having the ability to perceive your environment through sensors and then having some sort of actuators. it's a good starting point, but it's really rather academic in terms of definitions. But it's still widely quoted, this kind of generic definition of what an agent is. Of course, our good friends in the vendor community will have a bunch of definitions, and you will no doubt see a lot of slides from various vendors what an agent is. Most notable in this space is Microsoft. So if any of you going through perhaps the Microsoft Copilot journey, Copilot Studio with the agentics that are there, they've got a very opinionated view on what an agent is there. This morning we've had presentations from Snowflake with Cortex agents, very interesting. The Mosaic Databricks proposition, those guys have got a very view on what an agent is. And various of the vertical vendors like ServiceNow or Salesforce with Force agents have got their view. So really, there's not a lot of, I haven't found anything really useful in those kind of definitions. So this is kind of the best that I've come up with at the moment. So what is it? Well, it's a program. Okay, so it's some code. Could be some code that's produced for a low-code environment like Teams Copilot, or indeed it could be through an IDE in a pro-code environment. But what's special about this bit of code is that the developer, the person building it, the maker, if it's in a low-code environment, has given it some agency, some tasks to perform, and it uses a language model. Okay, if it doesn't use a language model, then it's a rule-based thing. There are some vendors that have, this is an agentic product, but it is a rules-type agent, so it might be doing things for you, but it's entirely deterministic. The important thing about the LLM is it will never do the same thing twice, and the agent will always find its different way through to achieving the outcome. So that's the kind of the core of it. The difference between an agent and a chatbot is that in the chatbot, you're giving it a specific goal or a task to achieve. Obviously, in an agent, you're giving it a goal. In a chatbot, you're just interacting with it. Perhaps you're asking it to summarize stuff for you, but it's a kind of interactive thing. And then the other defining factor is that it uses tools. Tools are largely synonymous with connectors. And then under the connector banner, it includes APIs, the ability to open files or databases or select from those. So kind of for me, that's really to have those 4 or 5 basic things if it's going to qualify as an agent. So a lot of people assume that everybody knows how the language model ecosystem works. So just quickly a couple of slides on level setting that environment, that ecosystem. So the large language model, so large in brackets deliberately there, is primarily made up of the big 3 proprietary models. So the OpenAI, and Anthropic and Google. Microsoft partner with OpenAI, and that's where you get your ChatGPT from. That was launched in November 22. AWS partners with Anthropic. Google is a full stack, so they actually run the cloud and build the models. So you're familiar with sort of Demis Hassabis and Google DeepMind, that's where that comes from. And then you've also got Meta as probably the most significant non-proprietary one. And the important thing is about the proprietary models, so ChatGPT, Claude, and Gemini, you can only really get those through an API. You can't download Claude and run it on local compute, whereas Llama, you can download that and run it on your own compute. So there's a big difference there, and obviously you have to pay for the API calls. Your usage of the model is entirely consumption-based. And the models themselves, so these are families of models, and then within the families of models, you get individual model members, so the Haiku, Sonnet, and Opus in the Claude series, they're part of that family. There are also a lot of churn on these things compared to, take a service like S3 or Redshift, the very stable service has been around a long time. The churn rate on models is quite fast. and they do not guarantee when you start to call the models that they will support these models for six months even. You suddenly find that your application, your agent, is behaving differently because they've actually deprecated a model. So that's if you're a large enterprise and you're used to things being very stable, you actually start to have a worse end of service life problem because you're going to have to start evergreening these technologies. So that's a factor that you have to get used to more. And then on the right hand side we have Hugging Face. So Hugging Face, not a foundational or not a model provider, but they're the center of the ecosystem. So all the models are kind of published through there. There are hundreds of thousands, if not a million or more, specialized models there. They are smaller because they are built from or fine-tuned or knowledge distilled from the larger models. And those big models, generally you'll hear the term foundation model. That's when we're referring to those big models. They're trained on 500 billion, or even in the case of OpenAI, 1 trillion parameters, using hundreds of thousands of dollars of GPUs. So you're not going to do that. You might, if you're a very large organization, fine-tune the models. This morning, I think it was Kamesh was talking about that. You might use low-rank adaptation, but you're most likely going to build on top of those models with an augmentation. So, the stuff that Lena was talking about, the context engineering, you're going to build a good context and you're going to put that into those models. So that's kind of the language ecosystem. And so first of all, you really have to choose your model. And then when you think, okay, great, we'd like to use Gemini, you run into the next challenge, which is, oh dear, that model's not available in my region. So model pricing and availability is a new challenge, as is understanding what on earth it is you're buying. I remember in the early days of big data, when you had Hadoop, and you would go around to your application, your analysts, and you would say, how many MapReduce slots do you think you would need? And they would look at you like you're some sort of lunatic, because they didn't understand what it is. It's the same with tokens. So we all are coming to understand that tokens, sort of roughly speaking, a small word or a chunk of a larger word. Then you have to understand that you're buying. In the case, this is an example from Azure. I've got these figures off their pricing page a couple of weeks ago. You're buying a PTU, a provision throughput unit. A provision throughput unit is an instance of a model which will achieve a certain number of tokens in terms of throughput. So before you can even start using it, you have to kind of commit to a certain amount of capacity. And the table on the right there is showing you that if you live in the US, guess what? You have access to all of the models. Fantastic. But if you're in Australia, you have access to about a third of the models. I was recently looking at a use case where we wanted to use the transcribed model, but unfortunately the transcribed model is not available in Australia, and because audio transcription is latency sensitive, then we couldn't call the US model, and anyway we would have had sovereignty issues taking stuff out of Australia. So these are all new challenges that from when you're building a data engineer, because it's all built on the LLM, you have to start worrying about these type of things. Okay, so the next session then is really looking at patterns for the agentic data engineering. I'll explain that we have a program which is given some agency. It's using a language model. It's goal driven, and it's got some connectors. So let's look at, okay, we assemble those programs. How do we assemble the chunks of code, the program units, into useful things to do work for us? And then from that, we'll build up a picture of, okay, this is a set of programs might look like an agentic data engineer. So I'll go through 4 patterns. There isn't a singular agentic data engineer. Perhaps when we get to the kind of AGI, we might get something that's good enough, but generally no single model will hold enough context. They're like people, if you give them too much context, their brain wanders off and they don't stay on topic. So you have to kind of break up a large task into a number of smaller tasks, and we use kind of multiple agents to decompose that into manageable chunks. So these are 4 common patterns that we've seen. The solution that I'll give you at the end as kind of a hybrid of 3 and 4. So the first pattern, which you'll see, is like kind of singleton or twin. Really, you rarely see a single agent. You normally see a twin. That's just a quality thing. And what you're doing is you're giving it a task like read some source to target mappings and then interpret those. And you'll always have a second agent which is reading that generated content and judging it in terms of quality. So it's sort of akin to a data quality or assessment function. And that's quite a common pattern. Seen that used in case management systems where you'll want to effectively one agent to summarize perhaps a call center call, and then another one to just check that did that accurately reflect that, is it appropriate, and so forth. So that's kind of quite a basic kind of building block, and you'll see that used in part in the data engineer at the end. Another basic pattern is the sequence. So again, you take your large task, like building the end-to-end pipeline, and you say, okay, do a pre-processor, now do the transformation, and then do a post-process. So as a fairly sort of simple sequence, you've got just one artifact between each point of the chain. Where it starts to get more interesting is where you move into delegation. So this obviously starts to look like a team structure, and there's a lot of parallels here between designing team structures and actually designing agent structures. And so in this case, you'll have typically an orchestration agent who will own the overall task. You'll tell the orchestration, the manager agent, you have access to these specialist subtasks, and then and maybe in the bottom tier, you'll have agents that specialize in talking to particular systems. So that agent can talk to Confluence, that one can talk to GitHub, and they will be able to coordinate. And so the task gets broken down and pushed between that, and obviously there are dialogues back and forth up and down that hierarchy. So that's the kind of delegation. And then if you want to scale out and you want to achieve things at speed, you'll hear two people talking about agent swarms. So an agent swarm, and a good meta for this one that I found is like the big data map reduce pattern. You take a large problem and you give each chunk of that problem to a specific agent, and then you can just swarm horizontally and accelerate if your end-to-end cycle time is taking too long, then you can just scale out your agents horizontally. So that's kind of how you get those things. And so those are kind of some basic patterns. Now, if you apply those patterns to the business of data engineering, then not the whole process isn't, you don't just try and do everything from requirements through to production. You then basically look at, well, what is the repetitive part of the process that we as data engineers go through? And it's that process of going from effectively the source to target mapping through to the having a debug set of code. And so you'll be able to have one agent that's looking at doing the analysis piece, another one that's perhaps generating some metadata and some documentation, obviously the coding, which they're very good at, and the debugging of that code, the testing of that pipeline. So that gives you that first tested architect. And this is the kind of typical process. And you'll notice that you're not automating the whole process. You're just automating a repetitive part of that process. So that thing about, is it going to take my job? No, because you still need somebody to do all of the kind of stakeholder management, the quality management, and the kind of running. And also you have to, just like a member of staff, you have to monitor the performance of your agent. So there's a bunch of observability that you have to do around that stuff. So that yellow part is typically the repetitive part, and we can take something that might take many days or weeks and reduce that down to in a few hours or even a few minutes of work. And it's important, obviously, that the whole objective of the exercise and the purpose of it being to deliver data for the business to be able to create value with that data. That's not going away. So it's not a kind of silver bullet. So if we take those patterns and we look at that process, and we apply the two together, we end up with something that starts to look like an agentic data engineer. So this is the kind of prototype agentic data engineer that you might see. So on the left, you'll give it a system prompt. So you're an expert data engineer, you have access to these particular tools, you have access to an analyst, you have access to a developer, a tester. So the analyst will then potentially connect to where your source to target mapping is. So maybe you store that, and a lot of it, we've had talks here from Atlassian, so perhaps you're using Confluence to store that stuff in. You have obviously your code in whatever your repo is. So in this case, I've shown GitHub and using Jira for the pull requests. And then your analyst then will, okay, so I need to create a Python program or a PySpark program that does this source to target mapping, and that's the sort of size of task that you can give an agent to do. Obviously, we want this stuff tested, so you need somebody to write the test specs. So somebody's going to write a test spec, set of tests that you'll create. Test generator. So we had a number of talks talking about, the applicability of language models to generating test data. So that's another aspect that you'll do. And then obviously you execute your tests, and you need then a summarizer at the end to go bring that sort together. So once you have a framework like this, and particularly maybe you're using a lakehouse style pattern on top of PySpark, then you've probably got some sort of metadata driven framework for creating your actual code. So this may not actually write the end code Spark, but it may actually just generate the metadata. So it might be generating JSON files to feed into your framework. So that's another pattern I've seen. So there are variations on this stuff. This is just one pattern. I've seen several other examples here, so don't take this as kind of being the only way to do things. So that's the kind of basic prototype, and it can significantly accelerate figures. If I say a figure, people will quote me on it, but you're talking orders of magnitude faster. Obviously, you have to spend time to build this thing up front. So there's a lot of investment in there, and this stuff is actually more like a data science task or an MLOps task. You're working with the models, you're working with measuring the accuracy. You have to say, is it generating hallucinations and going off topic? So that process that could take much longer in terms of building that capability, and that's not really as I say, it's not really a data engineering task. But once you have that kind of framework, and I think we will start to see frameworks like this appearing in platforms. I've got one or two examples of applications where this is starting to appear, but this will be the sort of capability that you'll start to see becoming commonplace. Okay, so if that's the overall kind of pattern for an agentic data engineer, and it's important obviously to remember we still have the human in the loop there. The human data engineer is still part of this picture. It still needs to be change controlled, put through all of the normal rigorous checks before you actually deploy this stuff. So that's, you're going to be able to do things at orders of magnitude faster and quicker than you could do. Does mean that you'll have to be able to write these job descriptions in terms of what things, what the tasks are that the individual team members do or agents do. But once that framework's running, then you could produce many data products or many data assets, so long as you have business analysts who can feed you the source to target mappings, and you've done all of that analysis work. So perhaps we'll go on now and look at some of the agentic type products that are in the market now, and the future trends of where things are going in terms of the different patterns of use that we are seeing. The current set of agentic data products, I don't know how many of you were watching any of the keynotes from the recent summits. So Snowflake had their summit earlier on in June, and Databricks had theirs in July. The first big area that we're seeing is migrations. So migrating either pipelines and or complete platforms from an on-prem database to a cloud one, or perhaps from a lakehouse pattern. From a data lake pattern to a lakehouse pattern. These things are very quickly getting commoditized. Databricks announced LakeBridge. That's a fully automated service that will actually read PyStar and migrate you to a new environment. Datafold is a very interesting company. They have a fully agentic, what do they call it? The Datafold migration agent, and they claim 10 or 100 times faster in terms of doing data migrations. I don't know any of you have done platform migrations, but they are generally very painful and generally time-consuming exercises. So I think that's a tremendous boon if fewer of us have to get involved in those kind of migration style products. Obviously, Jamak was keynoting here. She has starting to build AI into that product. I don't think that's really agentic. That's really more of a assistant to build those product specs. But still, Nextd is creating the JSON files for the data products to go into that platform. So you're starting to see it broaden out into the adjacent parts of the lifecycle. Microsoft just released data agents in Fabric. That's just come into private preview, and so that's obviously there's going to be a large community of that tends to be aimed at the small and medium type products that are the sweet spot for Fabric, Microsoft Fabric, and so there's a potential for a lot of sprawl to be created there. The thing that concerns me on these things is if you don't have good coding standards that you feed into the agents, then you're going to end up with every pipeline being slightly different. So it's very important if you have coding standards to feed those into the context windows to say you need to code it in this way. Your naming rules still need to be followed. If you don't have them, use some generative AI to build some coding standards so that when you build your agentic frameworks, then they're built to a quality standard. The Snowflake Cortex stuff we saw there this morning, quite a nice demo of that stuff in the keynote. So it's already here in some products, and it will grow further and further because it's making things much more efficient. Always trying to predict the future is a dangerous thing. I'm going to just refer to an article. I don't know if anybody's read Steve Yegi's very entertaining blog post. I recommend reading this one, The Revenge of the Junior Programmer. So I'm published on Medium. He talks about these kind of 6 waves. So the kind of traditional programming, which will decline. These code completions, which came in probably 4 or 5 years ago and accelerated with the launch of generative AI. There's phenomena of vibe coding. So obviously that's not something you should be using for any sort of production things, but it's useful for prototypes, that kind of stuff. And then through, you start to see those patterns I was referring to, sort of individual coding agents, right up to fleets of agents. So fleets being that kind of swarming pattern. And we're going to see that grow, quite quickly, and will actually accelerate in terms of the adoption of these agentic solutions. So, call to action then, in terms of closing out. Really, there's a couple of ways you can look at this. You can be like the Luddites and you can say, no, we're not having agents in our organization. It's definitely not going to happen. And you can be a Luddite and as they did and try and resist it. It didn't end well for the Luddites, guys. Okay, the weavers automated their stuff. You can possibly even be like Lisa and Bart and just go, it's not going to really have much impact. I genuinely think that's not really a good strategy. I think it is going to become very, very predominant. And I think it's good because who wants to do that kind of tedious cycle of having to debug pipelines? It really isn't a very a meaningful thing, particularly if they're other people's pipelines and you're having to maintain them. That's a particularly tedious one. So I've got a few thoughts in terms of starting places, a few practical ideas to get you started. So perhaps I'll sort of finish where I started in terms of, discuss with somebody in the coffee room what do we mean by agent in this organization, because I've already witnessed it in organizations where it's clear that those people are not talking about the same thing as those people, because they're thinking about that technology of agents and they're thinking about some other thing that hasn't quite been finished yet, and so they're not talking about the same thing. So you probably need to think about a taxonomy of agents. So maybe the agents that you build in Microsoft Teams might not be the same as the ones you build with Crew AI on your runtime kind of platform. So and starting that debate, because these are going to become important parts of your landscape, and you need to govern them. Most large companies will have some sort of enterprise application register. You have to figure out, are we going to put the agents in the register? Are we going to give them naming? How are we going to manage their access control? These are all kind of hard technical challenges, and so until we all agree what an agent is, then it's going to be really hard. So if you're going to say, the agents in that world are going to be authenticated, and these ones are just going to work maybe within Teams, Office 365, then that's kind of another world. What I spend a fair amount of my time on is watching videos. There's a lot of good stuff to help understand this stuff. So there's some good ones on Fabric, those data agents. There's some good demos now out there of agent bricks. So go and look at that stuff, try to understand how they work. Also try using the LLMs yourself to do a bit of vibe coding. Don't do it in production, but there are platforms. I've been playing around with Replit.com. That's kind of quite a nice platform which you can has a free tier offering if you don't want to get your credit card out. And it's remarkably good at writing Python. You can. What was the one I was doing last weekend? I got it to scrape a bunch of stuff off the BBC website, transform that, and then produce me a recommendation of the top 10 articles. Did that in about 4 minutes. It's really quite surprising. And the code it wrote wasn't too bad. There was no kind of functional testing in it, but it was interesting to see how that worked, get a feel for how it behaves. I already mentioned using LLMs to tidy up your coding standards and documents. You're going to need more and more of those stuff. I think the quality of documentation that you can produce with LLMs is sort of driving a gradual improvement in that stuff. And so, try cleaning that stuff up. I also plug for Peter. I think Peter's done a great job with this conference. Some great speakers. I like when he publishes the context. If you didn't see Lena's talk this morning on context engineering, I think that was really, really important to understand that stuff. So, because remember that your agent is only as good as the context you provide it. It only has the general knowledge. You have to provide all of that. All of your domain knowledge has to be fed in through that context window. As I said, finally, just try some out that vibe coding. Please don't do it in production, but do get a feel for what it is like to use agents. All right. So in summary, what is an agent? We need to define what an agent is. What are those patterns around building agents? The sequence, the delegation, the swarms, those kind of things. Have a look at some of those products in the market. If you have a dev environment, you have access to that. Turn on those preview features. Have a play with agent bricks. Have a play with Cortex, and see what those tools can do for you. But please don't ignore it, because it's not going away. I think the Agentic Data Engineer, is really a tool that will become a toolbox item that everybody is using, quite common. It might be 6 months away, it might be a year away, but I think if you look back probably at the conference next year or maybe the year after, quite a lot of people in the room will be using these agentic-based solutions. All right, there's a QR code. You can link to, feel free to connect with me on LinkedIn if you want the slides or anything. I think Peter will be publishing. So, but yeah, thanks. That's it for me.
Great.